All right, everybody, get ready. Because today we are going deep on Apache Iceberg. We're talking about managing data, and it's a lot of data, like truly massive amounts of data. You're going to want to stick around for this one, trust me.
We are definitely going way beyond spreadsheets here. Just imagine data sets so big they can hold tens of petabytes.
That's right, petabytes of information. That's the future of data storage.
Yeah, forget those old table formats. You know, the ones that completely break as soon as you try to do anything with them? Iceberg is all about keeping things running, even when you've got mountains of data.
It's like, all right, so you've built this super intricate data model.
Yeah.
It's a masterpiece with all the columns and partitions. But then your business needs change. You need to add a new column or maybe even change everything around. In the past, that would have meant a ton of work.
Oh, yeah. And it was always risky. It took forever.
Exactly. But with Iceberg, it's a totally different story. Schema evolution is simple. You can add, drop, or change columns without any problems. Wait, so I can add a new column even if I have petabytes of data? And Iceberg just handles it. I don't have to move the data around or anything.
Yep, that's right. Iceberg handles all the hard stuff in the background. It makes life so much easier if you work with data.
That's amazing. But what happens when my data grows? Like, what do I do when I need to change how the data is partitioned to make sure queries don't take forever?
That's where hidden partitioning comes in. It's a total game changer. Imagine you've got a table that's partitioned by day, but then suddenly you need to switch to hourly partitions.
Yeah, that would be a nightmare with most systems.
With Iceberg, it's actually pretty simple. Iceberg allows you to have multiple partitions, and it manages everything automatically. You don't even need to know how the data is partitioned.
So Iceberg does all the hard work, and I can just focus on writing my queries.
Exactly. It's like having a data genie taking care of everything.
This is starting to sound like science fiction. How does Iceberg query such massive data sets so quickly? We're talking about petabytes of data?
Iceberg has a really smart way of planning queries. It uses partitions and statistics to find the exact data you need. It's kind of like a GPS for your data.
So even if my data is all over the cloud, Iceberg can still find what I need quickly.
Yep, that's it. Iceberg is built to handle the challenges of cloud storage. It's all about speed no matter where your data is stored.
Okay, I'm convinced. We've got flexible schemas, invisible partitioning, fast queries. Iceberg sounds amazing. But what about keeping the data accurate? How does Iceberg make sure my data is always correct, especially when it's constantly changing?
That's a really important question. One of the core principles of Iceberg is something called serializable isolation. This means that changes to the table are always complete, so you'll never see an incomplete update.
That's good to hear. But what about when multiple people try to update the table at the same time? How does Iceberg deal with conflicts?
Iceberg uses something called optimistic concurrency. It allows multiple people to write to the table at the same time. And if there's conflict, Iceberg automatically retries the update.
So even if there are a lot of updates happening, Iceberg makes sure the data stays correct.
That's right. Iceberg is built for the real world. It's designed to be reliable no matter what happens.
That's really impressive. So Iceberg can handle all these complex operations. It can manage petabytes of data, and it makes sure the data is always correct.
Exactly. Iceberg is changing the way we think about data management.
So Iceberg really is like a superhero for data. It
Yeah.
comes in and saves the day. But I want to know how it actually works in the real world.
That's a good point. It's one thing to talk about all the cool things Iceberg can do, but we need to see how it actually performs.
Exactly. Give me some real-world examples. Who's using Iceberg, and how is it changing things for them?
Some of the biggest tech companies are already using Iceberg. Companies like Netflix, Apple, and Airbnb.
Wow, so Iceberg isn't just for data nerds.
Nope. And these companies are using Iceberg for a reason. It makes their queries faster, it helps them keep their data up to date, and it makes everything more efficient.
So these companies are actually seeing the benefits of using Iceberg.
Yes, they are.
But is Iceberg only for huge tech companies? Can smaller companies use it too?
Of course. One of the best things about Iceberg is that it's open. Anyone can use it, no matter how much data you have or what industry you're in.
So Iceberg is about having the right tools, not just the size of your data.
Exactly.
I like that. So we've got schema evolution, hidden partitioning, fast queries, and real-world use cases. Iceberg sounds amazing. But there's one thing I want to talk more about. It's the idea of time travel.
Ah, yes, time travel. It's one of the coolest features of Iceberg. You can basically query your data as it existed at different points in time.
Wait, so I can go back in time and see my data from the past?
That's the idea.
That's amazing. What are some of the ways people are using this feature?
Well, for one, it allows you to make sure your queries are always using the same data, even if the data has changed since you last ran the query. This is really important for data science and analytics.
Makes sense. No more wondering why your results are different from last week.
Exactly. But time travel can do even more than that. You can use it to see how your data has changed over time. You can find trends, anomalies, and all sorts of insights.
It's like having a history book for your data.
That's a great way to put it.
But doesn't storing all those snapshots take up a lot of space?
That's a good question. But Iceberg is designed to be efficient. It uses a technique called snapshot isolation, so it doesn't have to create a full copy of the data every time.
So it's not like it's duplicating everything.
Right.
And this leads to another cool feature, version rollback.
Oh, yeah. Version rollback is like an undo button for your data. If something goes wrong, you can just go back to a previous version.
That's incredible. So time travel isn't just for fun. It's a really powerful tool for managing your data.
Definitely.
And let's not forget about Iceberg being an open standard.
That's a big deal. It means you're not stuck with one vendor. There are a bunch of different implementations of Iceberg.
And so different teams can use different tools,
Mhm.
but they can all work with the same Iceberg table.
Exactly.
That's really powerful.
And it's great for collaboration.
But what does being an open standard mean for the future of Iceberg?
It means Iceberg can grow and evolve. Developers can contribute to the project and build new tools and integrations.
So Iceberg is more than just a piece of software. It's a community.
Yes, and a very active one.
I love that. This has been an amazing look at Apache Iceberg. We've talked about so much, but there's one more thing I want to cover: data deletion and compaction.
Those are important topics. They're not as flashy as schema evolution or time travel, but they're essential for keeping your data clean and efficient.
Right, let's dive in. So we've talked about all the cool stuff Iceberg can do, but now let's talk about the less glamorous but still important stuff: data deletion and compaction.
You got it. Those are important too. They're not as exciting as time travel,
Yeah.
but they're crucial for keeping your data clean and organized.
Okay, so let's start with data deletion. Seems pretty simple, but I bet there's more to it than meets the eye.
You're right. In old systems, deleting data meant rewriting whole files, and that could take forever, especially with big tables. But Iceberg does things differently.
How so?
Yeah.
Does it just magically make the data disappear?
Not magic, but close. Iceberg uses something called delete files. When you delete data, Iceberg creates a new file. This file is like a list of rows to ignore.
So it tells the query engine to skip over those rows.
Exactly. So when you query the table, the engine sees both the data files and the delete files, and it filters out the deleted rows.
That's pretty neat. But what happens when you have a lot of delete files? Doesn't that slow things down?
That's where compaction comes in. It's like cleaning up your Iceberg table. It merges small files, and it removes deleted rows permanently.
So it keeps things organized.
Yep, and it makes queries faster.
Okay, that makes sense. So Iceberg handles deletions efficiently, and then compaction keeps things tidy. But do I have to do all this manually?
You have some options. You can trigger compaction manually, or you can schedule it to run automatically. Iceberg can even handle it dynamically.
So I can choose what works best for me.
Exactly.
This has been an awesome deep dive into Apache Iceberg. We've learned so much, from schema evolution to time travel, and even data deletion and compaction.
It's been a great discussion.
Iceberg is really changing the game. It's making it easier and faster to work with massive data sets. And it's doing it in a way that's reliable and efficient.
I couldn't agree more.
If you're working with big data, you need to check out Iceberg.
You won't regret it.
Thanks for listening, everyone, and we'll see you next time.